My name is Xushen, and hello, everyone. Today's topic is about GitLab at Stanford. So all these words are really not that unfamiliar, right? GitLab, Stanford. Anyway, I have Mo and Marcello will be co-presenting some of the presentations. Let's move forward. Oh, before I go, I want to ask, how many of you are already familiar with Git? Raise your hands. Oh, I think we can end here, right? All of you. And subversion? Subversion? Wow.
Forgotten everything.
SVS? Pharmacy? Where you get your prescription? Everybody, right? No, you're so healthy. Anyway, those are just some revision control system, and Git is one of those, are really, really popular these days. So today is really about Git and the platform that supports Git hosting. Here is what we are going to do here today. Not, if I already feel bored, you can go Pokemon hunting, whatever, I don't mind. But, if you're here, maybe you are interested in this. We are going to briefly introduce GitLab and as a general open source platform, and then we are going to talk about Stanford implementation. For the people who are not really familiar with this, if you know, like I said, you can do multitasking. And after that, we are going to do some really get your feet wet. We are going to walk through sign up process, and we will look at the dashboard and what you need to be aware of. Then we'll create a project, together. And after that, Mo and Marcello will be present a workflow, a practical workflow. Because you have Git, you are probably already using it, but sometimes you walk into a new group of, you're just starting, right, with Git. You may want to set up some ground rules, how we are going to work together as a team, where to start. I run into problems that I do some thing I like to do. I just, hide in my office, start coding, and I submit my, merge request, fix this problem, and another person say, hey, I was working on that too, right? That's not good workflow. Anything it takes longer than 2 hours, maybe you should let your teammate know. And we'll talk about security. There are plenty of topics on security about access control, project visibility, branch protection. You want to control when this change can be actually rolled into the production. So that's covered under security umbrella. Then I really like to talk about this really new modern concept of continuous integration and deployment. And Slack, how do you tie all this together? So it's kind of like from the ground floor, and we are go up to the 3,000 feet. But stay with us if you can. I think it'll be good. Okay. GitLab, the very first thing I want to talk is really very basic, is Git hosting. It's a place you put your code, your documentation, your software, in a place that they are safe, right? Git, like I said, is like other revision control system, but it's really by far really very, very popular, especially in the developers. In the big enterprise companies, maybe Subversion is kind of dominate still, is control. But Git, because of its distributed, decentralized way, is more popular, give developers more flexibility. So why do we need a revision control system at all, right? So I listed two. There may be other reasons. One reason is audibility. Who made what change at what time is very once you committed to your central repository server, you cannot change it. You're not supposed to change it, because other people already see it. They may fork your repo to another place. So the change you published is go down to the history, cannot be changed. Okay, and then you know who did what, and that is actually really tied into immutability. It's frozen in time. It's a snapshot. You know, for the storage guy, I see somebody in there. It's like a disk snapshot. It's that you can be. It's versionable. You can use it to roll back, forward, right? So like a version, like server versioning tool. And I mentioned the distributed model. When you this is different from Subversion, that when you clone or you fork a repo from a central repository, it's on your laptop, on your desktop, is a full copy of everything. Basically, it's just you can take it away and you can work it offline, online. When you commit, it doesn't really go to the central repo until you push. So that is one major difference. Be aware that when you use this kind of model, right, when every developer has code in there all over the place, you're really supposed to guard your repository, because if this person leaves, you may have some information in there. You want to rotate, you want to change, your key should be changed right away, because you cannot, I guess it's hard to get into that person's desktop, say, okay, I want to wipe out your repo, right? So just be aware. That's very organic, really hard to kill something in here. By the way, if you have any questions you want to ask that is not what you want me to clarify, just feel free to interrupt me. And if its answer is within 1 minute, I will answer it. If it's more than 5 minutes, I think we'll maybe table that for later FAQ. So let's cover the Git hosting. There are many Git hosting places. If you already use Git, I'd like to know who are your provider, who hosts your repo? GitHub, what, Bitbucket, they're doing there. Anything else? Any other service you use?
Sure that GitLab just happened.
Yeah, GitLab sent to you. Okay, so that seems right into the topic here is really web hosting, and I like number 8. No, exactly. And 10 features in here already. So it's not just repository, okay? It's a platform. It's a web service. It's more project focused. You can manage the whole thing, almost everything in this platform. You can do issue tracking. You can manage namespace, who can access to my repo, membership. You can do your wiki documentation in there, and code review and discussions. That is one of the most important tools to facilitate this kind of feedback, code review. And RESTful API is very well, nicely documented, and you can do automation with it. And continuous integration, and this is quite new, maybe last 2 months, new feature. I really love it. I spent last few days, trying to play with it, and at least we should know there's such thing in there that totally under your control. There are tons of service integration you can tie in with other applications. We'll touch base on that. And it's open source. Everybody can contribute. And so when we take it, we install it, we do not pay license fee. So it's really, really nice. So it's a web service. Git hosting, web service platform. Now, why do we need it at Stanford, right? I just ask people who use the Git in here. It seems we have GitHub, we have some Bitbuckets, but really I really feel we have, for these many years, we have a hole here for Stanford community, that we have Google Docs, we have Dropbox, we have so many different storage, documentation sharing platform. We don't really have a nice one for campus developers. In old days, project kind of limited to one group, right? But these days, it's sometimes you have somebody from GSB, from university communication, from UIT. You work together. You want to share, and what do? If you host your projects in GitHub, in a private organization, you have to pay a license for me in order for me to actually join your project, right? And it's become more and more not really scalable. So that's one reason we want one at Stanford. And also we have integration, nicely integrated with Stanford authentication system. You sign up, self-service. There's no ticket needed. You just sign up. If you want to sign up now, go sign up. Otherwise, like, maybe you can crash my system if everybody sign up at the same time. It's code Stanford EDU, okay? It's implemented in the cloud and containerized. It's already modern. And the reason for doing that is that it's really lower the upfront cost because you can scale as you go. Before today's tech briefing, I use a T2 medium, really small machine. For today's tech briefing, we changed the size to M4 large, whatever. It's really doubled, the memory and the CPU. Just to prepare, because last time I did a presentation, I didn't scale up. The system did crash, right? So cloud and containerized make the whole operation is really low cost, also labor, less labor intensive because the way we build it. The way we build it, just very short. This.
Quick question. You're mentioning shared collaboration, but also WebAuth. We often work with third-party vendors. Third-party vendors who are not Stanford, can they collaborate?
Okay. The question is that I know this is coming. The question for the people on the phone is that you can, this platform, right, collaborate with Stanford people easily. You can assemble your own team. What about outside third-party vendor? Technically, yes. GitLab support external account, and if we turn on the login page, there'll be multiple boxes that you can actually use your Google account or use even GitLab its own username password to create account to do the sharing. But we disabled that for now. Yeah, so we can look into that and even maybe integrate with work group. You can have a group and mark them as external group, and we can integrate that way. But right now, it's disabled. Yeah.
So you have any? Because to be honest, that's like for our field.
Okay.
That's just won't be a mailing list.
GitLab or mailing list.
For obviously GitLab and finding out when we're trying.
Okay, so the question is that if we have any feature change down the road, or if you have anything you want to ask us to add on, where to send this kind of request. We do have a help SU link that when you sign in, if you search FAQ, in that one of the FAQ is where you send a request. Yeah, look for that. And I do realize that this external vendor thing, GitLab is getting better and better to try to protect, because they really want to limit this external vendor, right? You do not want them to become a member of your group, yet you want to give them some access to just maybe one of these projects. So that's kind of complicated. That's why initially we disable that account creation, and we need maybe prepare for that. But there's a link. If you have any questions, send to that link.
I'm going to ask, if you change your current policy for vendor, do you have any kind of like newsletter and announcement?
Okay.
I'm not going to ask
I don't have something right now.
Isn't the GitLab users?
GitLab users communication, that's a mailing list, yeah. I'm thinking more official thing, something UIT newsletter or something like that. Yeah, I mean, definitely if like an upgrade, downtime, if we have new features, there's a GitLab dash users mailing list. Yes. Yeah, everybody sign up should be on the mailing list. That's I guarantee. Okay. Yeah, you'll get subscription automatically. Okay. Any more questions? Okay. So this is how we build it. is on AWS, and you go through a load balancer, which is on Route 53. And after that, we have two protocols, SSH and HTTP username password. We recommend you to use SSH connection. We'll talk about that later on. And then we get into the EC2 machines right in the middle. Those are the applications, and they are actually running on EC2 inside of container. And all the data is outside of the EC2 container. So when the machine goes away, your repo, your repository, your file, your treasure is actually safe. The file system is a really new, is a AWS NFS version 4 storage called EFS, Elastic File System. It's a kind of pay-as-you-go file system. And each repo on EFS file system has 3 copies in 3 zones already. And then we also do nightly backup. So the backup goes to S3 bucket. So that's another copy over there. So it's quite nice. Questions in here? No? Okay. I think that's really a lot of features and talks in there, and it's time for us to go sign up. You all sign up? Okay. Yeah, no crash? Still up? So sign up, I guess you already did, and the other ones I talk about as SHP. For people who are new to the GitLab, you should do that, because really that each time you pull repo to your central repo, you do not have to type in yet another username password, right? Git is smart enough to find where's your private key and connect securely to GitLab server. And we'll create a project that will just demonstrate a very simple workflow. How do you work with repo? This maybe is too simple for many of you, okay? So, but I think that maybe still worth going through this. Okay, so I'm on my terminal, and okay. Fine. I'm already logged in. If I log out, and I hope I can still log in back. And log in. Yeah. Crashed? Oh no, it didn't. This is your landing page that you can configure in your profile. I like to see my activities. Some other people like to see all your project, right? So you can really configure it. If you have hundreds of projects, this page may be slow. It's hard to load everything. So you may want to say, oh, I just want to see activities, right? So everything you can configure is actually hiding in here. This upper left corner, you can expand.
The other thing you did to have access to hundreds of repos, if you don't star any of them, you can actually change your default to star projects and get a blank page.
Nobody star? Yeah.
Could you repeat that for those on Bluetooth? About the starring
configuration?
No, the starring and being able to.
Oh, okay. So like I have hundreds of projects, whatever. It's really slow, right? But you can configure that in your profile setting. They have options of your activity, your projects, or start project, or trendy project. If you go star, because people, I don't know, they are very high standard. They don't really easily go start people's projects. So you don't get very few start projects, and your page will load very fast. Right? Yeah. Okay, you configure in here, and real quick in here, you're not supposed to change your account's information, okay? Especially your email and your identity. We pull this from central IDP, from attribute release. We get that from there. If you change it and it doesn't match, next time you try to sign in, it will say, it will give you a 402, email address already being used, something like that. So try not to change this. Other things you can change, right? You can configure your account. I will not have time to go through all this, but you can just go play with this. The thing I want to mention is this SSH key. I have plenty of keys already. You may have one or maybe you have many. It depends which machine you are working on, right? If you have a key on this laptop, you do not upload your key on another laptop, next time you'll probably not be able to push pull. So you do want to put your keys that you often use into uploaded in here. And you have link in here that has really nice instructions to tell you if you are on Windows, how do you generate the key? If you are on Linux flavored machine, how do you generate these keys? So I'll not go through this. This is really, really simple thing. You just go there, you cut and paste your public portion of your key. It even tells that, you know, the small thing, it actually reminds you don't put your private key in here, just public key, okay? So when you have that, now namespace. There are just two namespace. One is personal. Everybody has a personal namespace that goes through / your Sonnet ID, and project you create, if you can create it for yourself. You know, I think we have a 10 or 20 limit that for people for your personal project we can bump that up. But there's really not much reason you just use it for your own, right? If you are serious, you want to, you know, make a work group space that you can share code with other people that way. That's a way you can actually set default access control in one place for, you know, in a group. So group namespace, we have no limit, and everybody can go and create namespace. We do not have any tie-in into our campus work group. You just free for, right? So I'm going to create one here for you go here, you go groups, and I can create something. New group is here. I say I already practiced this for tech training, and then you see there are visibilities in here. Usually you have 3 levels of visibility, but we disable the public visibility. So you can only create private and internal. Private is private to your own members in the group, and internal is visible to all the people who logged into this platform. For anonymous people, they cannot see internal people, group and project. The reason we block public is really because sometimes people accidentally create some public project and didn't know they leaked something. So we think we'd better just make it more restricted. So once you cannot, when we have that public blocked, so you cannot create a public project. Also, the group membership, if we enable that, the group membership will also be visible to non-authenticated user, which probably is not ideal for you either. If you really know what you are doing, you really want public group and repository, you can let us know, because admins can actually create this kind of public type repo and group. Okay, so by default, everything's private. So my new group by default is private, so I can maybe make it internal. Wait a minute. And I have a group, I can invite people, members. I don't know who is who, I can just maybe type Mo. You can search, you know, and you can, when you add group, you can give it so many different, you have this 5 different kind of role you can pick from. And guest actually is not anonymous, okay? Guest is also people who are already like logged in, who has a certain privilege already by default, like they can submit issues against your repo. And there's a long list of who can do what, which I will show you later. You have reporter. Usually I give my manager reporter permission. So I think my manager probably want to see status and all that stuff, but maybe not interested in commit some change to my repo. It's a lot of flexibility here. Okay, I think it's much more fine-grained than GitHub. You know, as far as the visibility and access control concern. So I'm going to give more developer permission and add him here. So there you go. I have a group. I have member in there, and I want to go maybe create some projects in here. What? Tag training and Git, as my one, and the one group you can have many repositories. The default permission for the membership apply, but you can also control access per repo on per repo basis, and the highest permission take priority. Yeah, so you can play with that. And so my here, I think if I try to make this to public, I probably will get rejection because at the top level, it's blocked.
Specify what group it's part of.
You just create a new group.
I know, but you're a member, I presume, of several groups. When you're creating a new project, how do you tell it which one of the many groups you're a member of?
You show the little group project creation.
Yeah, I probably created in the wrong place anyway. So yeah, all right. Actually, I meant to create this one in tech briefing, but I did it wrong. So here, when you create a new project, you can pick, the groups. You only can create a project in the groups that you have permission to, right? So I have this under my thing. I just created a tech training, and I'm the owner, so I can create my project in there. Okay. Yeah. So the question actually is very important. When you create a project, do remember to check which group you actually put that project repo into. I think the problem this morning we had is yeah. Okay. I go back to make this internal because it wouldn't let me do the public one, so I can do it again. And this should be really the GitLab is try to be really helpful. How do you get off ground and how do you use it? So the very first thing is ask you to go to your terminal to configure your identity. You want to identify yourself because we want your change to be auditable. So you have your username, your email, you can configure. See the git config global there is really, that's the default. If you do not have a configuration per repo, this will be your default. When you commit, that carries your name, your email into your commit history. It's also configurable. If you check out a repo, right, you go to that repository, and if you can still do git config, and if you remove git -- global from the command line, it actually config that your identity, your author information just for that repo. So you can pretend I'm here, I'm Bruce, and I'm there, I'm Xueshan. You can do that kind of trick. Anyway. There are two ways you can create a repository. One is just a brand new, and one is from your existing folder, right? I'm going to use the create a new repo in here for the demo. And also by doing that, I'm demo a very simple centralized workflow. That is one master branch, no other branch. I just work on that one repository. So basically I can just cut and paste in here, right? And I go here. I can clone. So by cloning, I'm actually talking to my GitLab server. I get a whole copy of my repository here, which now is actually empty. And if you by default will go to this directory, go to the directory named after this repo. So this tech training, right? I go here, everything is empty here, nothing in there. And I can just do a very quick, just a readme in here, not wasting people's time. So GitLab tag briefing, and I can say one, getting started, new workflow. You can go on and on, right? So I'm done, and I just save it. And if now do status, right? it actually tells you it's untracked file in there, which is really, you are safe here. You are just delete it, re-edit it, put something there. It's nothing you can, nothing hurt, untracked. Now I say, I'm ready. I mean, this is a good file. I want to prepare it for commit. So you will do I always remember 3 steps thing: add, commit, and push. So I'm doing add. By doing add, I'm putting this thing in my staging area. In my staging, it's not even in my personal repo, working repo, local repo at all. It's still in the staging. And then I do commit. I can do initial, repo, whatever. Now, if you do status again, it actually nothing. Nothing new to commit. I'm ready actually to push my local repository change up to the central for people to share. So I can do git push now. So origin is really about your remote. Git doesn't care it's origin or what, but by default in the convention, it's upstream is origin. So, but you can name it with other name, but you have to make sure you are pushing to the right remote because you can have multiple remotes. So I'm doing this. It's up in there. If I do status now, everything's clean, and I go back here. This page will go away if I reload because this only show up the first time when you create a new project. So I reload, and typo, yeah, typo. Otherwise, my README file will be my landing page. It will show up in the very first page because I typoed. It doesn't read it. Git just treat it as a regular file. Okay. I'm not going to correct this one. It's okay. I just wipe it out later. Yeah.
Could you explain again the push origin? Because you've just done a commit which sends it up to the repository. Why do you then need to do a push?
Commit, yeah, that's why. Oh, I will repeat the question, right? The question is really I get confused too. Sometimes I forgot. So when you do commit, why do you have to do a push again, right? That's the thing. You commit, it's already there. But actually, that's the very major difference between Subversion and Git. Commit does not actually push anything to the remote origin repo. Commit is only committed to your local repository. You have a local repository. You have a remote repository. Commit is committed to your index, your staging work into your local repository. Okay, so you can. It's not. Commit is really prepared. It's a kind of a good snapshot now. I want to commit, make a snapshot in here. You can continue add. You don't have to commit all the time, but when you think it's a good point, do a snapshot that one so you can go back to that one, you do a commit. But you do not have to push. You can still continue to work until you're ready, and then you push. The push actually is publish it to the remote repository. Yeah.
So if I understand correctly, you've got working directory, you've got a staging area, you've got a local repository. Right. And then when you do the push, it sends it to the remote.
Yes, exactly. Yeah. So it's always 3 steps. Dance. It's not tango, right? I know tango is 4. Yeah.
I think one of the benefits of that is you work offline, like airplane, be able to do a lot of your work, get it, something,
yeah,
and then push that.
Yeah, I'll repeat that. Is really these extra steps really allow you to commit often, yet you do not have to connect to your server. You can work offline. Yeah.
Another defense is if you do something I'm not sure is going to work, it's kind of experimental. You can create a local branch, server, and you can screw up as often as you want. Couple of messages, and by the time I actually share with everybody else, merge it back into one of the other branches without doing an automatic commit. Instead of bringing all the history of all the mistakes you made, what we're trying to do is figure out one whole thing. You can actually merge it in, drop all the commit messages, and send it all in one message going, hey, I fixed a really weird problem.
We're gonna show it in the live demos.
Yeah. All right. So I'm almost finished my the very first demo, which is the sign up, upload your key, and create a group and create a project within that group. Add some members in there, and then do my edit, add, commit, push events. Right. I did all that on my master branch. And the next one, which is really okay for people come from the Subversion world, but you are not actually fully utilize the advantage of Git, which is collaboration, code review, feedback, all that kind of stuff. So with that, I'm going to invite Mo and Marcello to demo what we call feature branch workflow that Mo encourage collaboration. Okay, thank you.
Thanks.
Good afternoon, everyone. I'm Mo.
I'm Marcello, and we are all part of TCG.
Okay, M&M.
M&M.
All right, I don't know about that.
By the way, can you check make sure your screen is being shared in Blue Teams?
Hey, good point.
Sorry.
So I do cloud stuff, and we use Git quite a bit. Marcello and I are going to demonstrate a slightly more involved Git workflow. The cool thing about our demonstration today is we're going to do it all through the web UI. So if you're not familiar with Git and using it in the command line, you can actually do everything through just the web interface, which is really cool. It's a really easy way to get started with Git. This is what we're going to do. This is called a feature branch workflow, also known as Git flow or GitLab flow. You can read, tons and tons about it online. But the idea is that you commit to a separate branch, not the master branch, but a separate branch where you are working independently or perhaps with a team member. Sorry, let me back up. You start with an issue, which is like your task. You commit changes to a separate branch, non-master branch. And then once you are satisfied with your changes, you create a merge request, which is like a pull request if you're familiar with GitHub. And then you have a review process, which is what we're going to demonstrate. And then you, once the merge request is accepted, you can have it automatically resolve the issue for you. So it's just a way, a workflow, example of a workflow with GitLab. So we have this TCG shopping list. It's an empty repository. So we're going to create a shopping list. And the first thing we're going to do is create a file. And you can do this all in the browser. So
Beers for sure.
Yeah, ready.
TCG stand for
Technology Consulting Group.
Thank you.
What else?
Chips, chocolate, M&Ms.
Pizza, M&M. Fruit. Kale.
Yeah. Well, no. No.
All right.
That's too funny.
So I think this should hold us over for tonight at least. Now, you saw in the command line when Shushen made a commit, she was able to provide a message that kind of described the fact that she was doing an initial commit. So here you can type in your commit message. And usually you want to specify what it is you're changing or adding. In this case, we're creating shopping list for party. All right. So we commit our changes. And just like that, you have a Git repository and a README file. And you can see, because this file is called readme.md, the front page of the repo on GitLab is now the shopping list that we just specified. So when you navigate to this repo, you'll see whatever the contents of readme.md are. So into our Git flow or feature branch demonstration, we've got our list here. And now Marcello and I have decided that any additional changes to this list need to be approved by the team, right? So I'm not going to add, ribeyes and filet mignon because this is coming out of our team budget, and we want to get some oversight there. So the first thing I'm going to do is create an issue, and this issue is going to represent the fact that I'd like to make a change to our list. So let's create a new issue. I clicked on issues there.
It may be easier the friend saying, hey, I would like also have some Coke and Sprite added to the list. And so he's going to add it.
And you really like gummy bears, right?
Yeah, they do. I unfortunately
All right, so we've got our title of our issue. We've got a description. You could elaborate more if you needed to. If it was a complex code issue or a bug, it would make sense to have maybe some reproduction steps. And I'm going to assign this issue to Marcello, since he's the one who needs to review it. And there's also some interesting stuff you can do with milestones, more project management features and labels. If you need to group issues, feel free to explore that. You can also specify a due date. Anyway, so we now have an issue in our project. And let's go ahead and create a branch to make our change in, which from there we will create a merge request of. And then we'll hand it over to Marcello to do the reviewing. So we go back to our project's main page. You see this plus sign here. Now you can use this to add new files, a new directory, and create a new branch. Is everyone generally familiar with the idea of branching is in Git? Yeah? Okay. So let's create a new branch. And we're going to call it add drinks and candy. That's the name of our branch, and we're going to be creating it from the master branch. So all of the files and in our master branch will now be copied over into this new branch called add drinks and candy. And as we make changes, we'll actually push changes into this new feature branch.
Yeah, literally it's like a parallel universe. You just fork the status of your master branch into two parallel paths, and they both contain the same stuff at time 0. Now we can play on the sandbox, which is our branch, and when we collect all these changes, we can actually then go back.
As Scotty was mentioning earlier.
So it's not really a real copy, it's more of a fork, and we do that.
So as you can see here in this switch branch dropdown, we now have our master branch, which was the branch that the file was originally created in, and we have our new add drinks and candy branch. So in our new add drinks and candy branch, we're going to come in and click on the file we want to edit. We're going to click edit again, and we're going to add Coke and Sprite and gummy bears. Okay, any other suggestions? Good enough. All right. So added drinks and candy. Good enough. All right, so we commit those changes, and you can see the target branch is our add drinks and candy branch and not the master branch. So as Shushan mentioned earlier, you kind of want this idea of having secure production branches where only trusted people, senior developers, can actually push code into a branch that could perhaps in an automated way be pushed to a production environment, right? So this would, we're kind of illustrating how developers would work in their own branches, and then after a review process, that branch would be merged into a production release branch.
Okay. So you could of course have multiple branches going on for different things. So let's say somebody would like to bring a barbecue work, and so they say, let's say you need poultry to cook on a barbecue. So if you have that, how are you going to put it all back together again?
That's a good question. So you would create another issue. They would create a new branch, and you, as we so we're getting into the merge request part. So let me get to that. Yeah. Well, you actually specify the source branch and then the target branch. So the target branch in this case is always going to be master. That would be like our production stable code release branch, and that's specified in the merge request, which I'm going to create now.
I inferred from what you said that you have the permission not just per repo, but per branch.
Yes, yeah. Shushan's going to demonstrate that later.
It's really very, very new feature. You can actually protect branch. You can protect the name of the branch. I can take stable branch, nobody can create it. Things like that.
I was wondering if you can repeat the question quickly.
Oh, sorry. Yeah. Sorry. What's your name? Emma asked, how can we have multiple branches be targeted back towards our master branch? And that's kind of where merge requests come in, which I'm about to demonstrate. And JB asked, can we actually protect specific branches with permissions, allowing only certain people to merge into those branches, commit to those branches? And the answer is yes, we can. And Shushan's going to demonstrate that shortly.
Is there any reason why you do an add? And the reason I asked the question,
yeah,
I'm more used to changing a bunch of modules at a time, and I add them. Now I say, okay, I think this is the better change function.
Yeah, that's a good question. The question is, how come we didn't do an add here? Why was it just a change and a commit? And the reason is only because we're demonstrating this in the UI. We are using the remote's version of the repository as our local working copy. And it basically skips the step of having a staging area, right? So you modify a file and you just commit. Now, when you're working locally on your own machine in the command line or through a GUI, you're still going to have staging, commit, push. But when you work in the UI here on the website, you're actually just committing into a branch.
Yeah, you'll spare from that.
It's a simplified workflow, so you don't have to worry about a traditional Git flow or Git workflow where you commit and add, or add and commit and push. So we're adding, committing, and pushing all in one step.
One downside of the web interface is you can only do things on one file at a time. So if you want to do a commit or you need to modify some files, you have to but otherwise people can end up pulling down up to some point and happen.
Yeah.
Yeah, this use UI we are debating among ourselves is really try to demonstrate the concept of feedback code review. That can work for collaboration. Definitely this is not your proper daily way of working. It's always will be on the command line.
Yeah.
So this is really the concept that the more emphasize on the collaboration on the code review part of it and merge request thing. But everything you do here can be done on the command line. Doesn't have to be on the console.
Yeah. So we have our branch, our feature branch, and we have made our changes. So now we want to create a merge request, which will basically initiate our review process. And to do that, you come into the merge requests tab, and you click create merge request. So it notices that we just pushed to add drinks and candy. So it's going to suggest that we create a merge request, a new request for that branch. So we'll just click that button. And here we'll just add a description. So we're saying add requested stuff. And this is the cool part where we can actually say fixes number 1, and what that means is this merge request will resolve issue number 1. So when it gets merged, it will automatically close that issue. So it just kind of saves you a step of having to go back in and resolve the issue is done. Oh yeah, good, thank you. The other cool thing that you can do here is you can mention either your group, which will send an email to everyone in your group saying, hey, there's a new merge request that needs to be reviewed, or you can mention individuals directly if you're commenting on someone, a specific person's code change. So here I'm going to mention Marcello, and he'll get an email and say, hey, I added the requested stuff. I'm going to actually assign this to Marcello. I think we'll also trigger an email there. You can do labels and milestones in the same way you could for issues. And you can see, Emma, this answers your question, the source branch and the target branch. So if someone else wanted to contribute to our master list, they would create a new branch, and they would set that branch as the source branch, and then the target branch would be master. And we would agree as a team that the master branch was the definitive source of what would actually be purchased for the party. So, you can check this box here to remove the source branch once the feature branch is merged, and that's just some housekeeping stuff to where you don't have a bunch of kind of old unused feature branches laying around.
If you do that on here, and somebody else has pulled down this branch, and you go ahead and delete it up here on GitLab.
Yeah.
What happens?
So you can't. Obviously, you can't delete a branch off someone else's computer. That's the nature of Git. When you clone the repository, you're cloning essentially every branch and all of the history of every branch. So when we're deleting the branch here, we're like deleting it locally on the server. But now, if someone were to pull after it gets deleted, that feature branch would no longer be there because it got deleted.
Yeah, so the local server is the remote for everybody.
Right. But if somebody else has that branch and they were working on it, they could push it.
They could still, if you delete it and you push it again, I think it'll get recreated, right? Yeah.
Yeah.
Okay, so we're going to submit our merge request, and I'm done for the day. It's 5 o'clock. I'm going to go home, and now Marcello is actually signed into his account here.
Yeah, because we are using the same computer for business presentation. So I arrive home and I find this alert in the emails, and I see that somebody actually wanted me to review something. So I'm going to reload the browser. I see there is a merge request open. At that point, I actually click on it, add the drinks and candy. What's that? Let me see. So changes, let's see the changes here. So by clicking here, you can see the difference that have been applied and proposed. I see that fruit stays, well, that's healthy. Token Sprite, don't mind. Gummy bears. Hey, hold on a second. I didn't say gummy bears. I really wanted the specific model. So I'm going to actually complain to Mo and say, Mo, I actually said the gummy teddy bears. So I'm going to put now in the discussion of the situation, as a team, we agreed that the workflow requires that before a change is applied to the reference branch, the master branch, we need to have a thumbs up, at least one. Now I'm going to put thumbs down just to make sure it's not going to be merged by mistake. I don't want to end up with the normal gummy bears that I like. Right? At that point, I'm going to be just done with that, and I can go to bed and waiting for Mo to come back in the office in the next morning and apply what I just commented.
So here I am, and I refresh. I come back the next day. There's an email in my inbox that has the comment that Marcello provided saying he actually wanted gummy teddy bears, not just gummy bears. So let's go fix that. I go back into my project. Here's my file. Now, you want to make sure that when you make this change that you're actually on the branch that you think you are. Remember, there's a command line equivalent to everything that I'm doing in the UI here. And it's having to add. Okay, so here we are. We're on the branch that is associated with the merge request that we're working on. Let's go ahead and edit that change. Okay, so I think we just need to add Teddy here. And Marcello will be happy. And we're going into the branch that we want to go into. All right. I heard Marcello's phone, I think, get a ding. Maybe not. But so back over here, Marcello gets a notification.
Yeah, so I wake up in the morning, I go to the office, I actually open my computer, and I see the mobile. I made another change. I'm going to click here, teddy bears. Oh, finally, I see my teddy bears are actually in the shopping list. At that point, I'm going to go back to the discussion, and I'm going to be totally removing my thumbs down. Looks good to me now. I'm going to put thumbs up, and that's pretty much it. And then at that point, I can actually say, thanks, Mo. Anyway, Mo. Thanks for doing that. Looks good to me. And then I could either do this, comment and close merge request, but I want to just, let him do that because he likes doing some good comment. Then I leave it, and the Mo notice that he gets an email, and he can now do the final action.
So everything's good to go. We can now merge our feature branch into the master branch. And to do that, we come to our merge request and we click I approve it too. And I can just click accept merge request, and essentially we will now have the changes that we created in our feature branch merged into our master branch. You can actually enforce approvals in GitLab, so you can actually require that there be at least X number of approvals before it will even allow you to merge a merge request. Yeah. And you can also see that it says accepting this merge request will close issue number 1. So let's accept it. And ta-da!
There you go.
Okay, so all good. Now we come back to our project. We look at our master branch, and we can see now that we have fruit, Coke, and wait a minute. Oh, they're there. Okay, Coke and Sprite and gummy teddy bears. And that concludes our demonstration. Any questions? Oh, yeah. So yeah, just to recap, we demonstrated the feature branch workflow. And basically, again, that means you're working in a separate branch that is a duplicate of the original source branch. Your changes go there, and you start with an issue, you create a feature branch, you work in that feature branch, you create a merge request, you go through the review process in the merge request, and then you hopefully the merge request gets accepted, and then the issue gets closed automatically.
2 questions.
Mm-hmm.
One, I noticed we can do a push origin here. Why doesn't it require?
Yeah, again, the UI doesn't require it because we're actually working on the origin in this case.
And then show that it's a rollback. They want to roll back.
Sorry, the first question was we didn't do a push origin here, and the reason is because when you're working in the UI, you're actually working on the origin itself. So committing on the UI is like committing and pushing to origin. And second question?
Second question, for rollback?
Can you do a rollback? Good question.
It's possible, but we'll be actually beating the timeline we have now set for the presentation. We can take it offline with you later on.
I'm not 100% sure how to do that in the UI, but you could very easily do that in the command line.
Thank you. Thank you very much. Very good. Yeah. Okay, for drink and beer and things like that. Thank you very much. Okay. So we are not done yet. This is just the master branch, the simple, no feature branch picture, and this is their demo. And security, we only have 30 minutes, I guess. I have to really run fast. Anyway, security, single sign-on, use your Signup ID, username, password, that is really nice. And visibility, we have group and user level and project level of visibility. But for us, it's really simple now because everything is internal, private. There's no public. There's a link. If you are on the computer, you can click a link. Actually, explain what's the public, what's private, what is internal, and then access control. Access control is also a long list of things. It's long. Who can do what? Basically, a lot of stuff. And the things you want to pay attention is really branch protection. Those functions can only be managed by master and owner level. Developers don't get to define those. This is something you want to go, in your own time to take a look. I wouldn't spend time explaining this. This is too much. And because that's what about visibility and access control. And then we mentioned about branch protection. So when you have automated deployment, right, you really want to protect your production branch. You do not want somebody accidentally put something critical without any approval. So this branch protection is protect from creation some certain name like a stable production. No, you can just not just go there and create. You can prevent from deletion. Non-authorized. If you don't have the permission, you cannot really delete. Prevent from just push in there. So how do you do that? It's actually it's in if you go to your project, pick one project like my Docker, that it's in a lot of things you can do in project settings here, and there's a option in here called protect branch. And if you go here, what you can do is explain, what this actually do for you, just like the benefits, why in the use case, basically, right? Why do you want to use this feature? So say if I want to do protect some branch here, I already have two branching here, but you can do like production. As I type, it's actually try to match something. It's no match, right? Production just I can do it this way. This is no branch match my my name, or still wrong. Production, right? So, and this is an opportunity for you actually to preserve this name. So I can say, okay, create this for me. So protect. I can also say my developer can merge, and developer can push. It's up to you to pick which way you want to do it. So then I have two protected branches now, just for. I already have one stable. I created for stable version 1, and I have this production that I don't have anything yet in it. So basically, you preserve the name. Only owner and the master by default can push changes to this branch.
Okay.
Yeah.
This functionality is only on GitLab. It's not within Git, correct? Like, you can this down and put it up to GitHub or whatever these branches. Right.
It's GitLab. Sorry. I will repeat your question. Say it again.
I was asking if this functionality was in GitLab or in Git itself. Like if you clone this repo down and push it up to GitHub, would the branches still be protected?
It's only GitHub. The question is that is this feature is for is it a general Git feature or is just GitLab? The answer is just GitLab. Yeah. So branch, any questions in here? No, clear? Okay, so that's actually my next one is about CI. Integration. I mean, this is there are so many, maybe more than 20 different kinds of integration you can do on GitLab, right? So basically, you can see from here is everything about the project is actually on this gear button at the top right corner. And you can do integration with other services in here. Slack is here. Some I think there's also Atlassian, Jira. This different CI system. You can do configuration. Usually you have a token you configure in here, and then you can communicate with the other application. So that is in there. Project settings in here. Yeah, everything. Branch protection is here. Service integration is here. Webhooks for your Jenkins, for something you can create. Jenkins is one of the most popular CI system. You can create your hook in here. So these are the integration you can do. It's very actually many services you can do. I have not really played all of this. I did play it with Slack, which is I'm going to get into. Slack integration. Not too many. Okay, back to my demos. This is that the settings is in the project setting page. You can do your integration part. The CI is the most new feature that just like maybe last 2 months, 3 months thing. That is integrated with, built in with GitLab basically. Before your CI server, like Jenkins, is outside of your GitLab. This is actually integrated in there. You can trigger a CI job within GitLab, and you can see the job running dashboard actually within your GitLab UI system. You need 3 things to have this going. One is GitLab server, which we already have, the central server. The other one you need is they call GitLab runner. So the runner is binary, one Go binary. Anybody know Go is the very trendy language that used for all, in the container world, in the very high demanding language, which is actually Go language is produce a binary static linked binary that you install on the system. It just one binary code. So runner for GitLab, you can run it on your laptop, Mac. I think there's a Windows version 2. I have to really check into that. All the Linux flavor, you can install. There's a URL, you download, you install, and you start it, and then it becomes a process on your system, and it will actually talk to the GitLab server through API. So that's the whole architecture. So we can show things here, your runner on your laptop, your runner on your computer. So, and then the third thing you need is really you need a recipe, right? You need a file to tell your runner what I'm going to do with your code. So I'll demonstrate that with my Docker, I'm going to demo with this flow, right? We're going to create a Slack channel for notification. So when I build, I get notification. That's I want to know. Using Slack give you some flexibility that you want your ops, maybe you want to know what's happening, but you do not really want to give them any access to your repo, right? That's one use case in there. And I'm going to create this runner that I need a token, and I create a runner, and then I'll create a job to define my CI job, and then I'm going to commit some change to my repo to trigger. So CI is really nothing really that fun, that new. Many of us already using this kind of concept, which is really automation, right? It's automate your process. You can have documentation step 1, 2, 3, do something. You can code it this way, but it's still not good enough, right? When you actually use an automated CI system, you have your machine actually knowledgeable. Machine run your knowledge. So if someday, your lead developer, get, going out to make some big money, you retain all the knowledge because of the code is in here. So codification automation is really, really important, even for something as simple as that. Here, this shell script is just clone my repo, which is a Docker application. Under that application, I have a Docker file, which is a manifest about how I'm going to build my image. So I'm going to build my image. After the build, I tag it into Xishan/Docker node app, and I push it up to a public repo. I have my credential on my own machine, so I can push it without being challenged in here. And then I want to test, right? I test by pull back my image, and then I run it in my local port 8000 and do a curl. And if the curl is okay, my application is thumbs up. If not, I'm not going to do the deployment, right? I will just, okay, I have some actually, never mind. So if everything's okay, I will write on my port 80 deploy into production so I can actually go to my website. So how do we turn this into a CI job, right? I'm going to do that in here. Let me go to my Docker, so it's in my own namespace. I'll search my code. Node app is here. And remember the thing I really need, I need my token and my my runner token and my endpoint, like my machine can do API callback. So I get it from here, from my project settings and the runner type. I get these two numbers, right? I already have a runner set up on my machine. If you do a process listing on my machine, you can see my I have a runner running on here. It's talking to my GitLab server. I do have a code to do all the installation automatically. You know, as my boss said, if Xishan do it once, Xishan will code it. So that's what I do. I have a runner wrapper here, and this code actually what it does, it actually downloads the binary for my Mac, and it will get stored. I will put my CI token and my CI server name in my local file in here, and this code will download binary and register. This here is actually a function is doing the register. Use my CI token and see my server name to register this runner to my server, you know, in the cloud, you know. So it does this all for me. So I can do GitLab runner register. You can register many runners on even on one laptop. Doesn't really matter. You can tag your runner. I tag this one as shell, which means that when my job runs, only run the command that is available on my machine at shell level. You can have some different runner. You can tag Java, you can tag Ruby, you can tag this is Docker. I need to run Docker container. And so when CI allocate a job, when you write your CI specific manifest, you can say, I want this job to run on Java tag or run shell, whatever, right? So I have shell. So this is running in here. If I go back to my here, if I refresh, I should see a new runner, right? I did see a new runner in here. That's I just registered. I can remove this runner. You know, just take one away. One thing you can do is you click your runner configuration. You can restrict this runner only for this particular project. I don't want to share. I'm really mean. I just want my own thing, this one particular project running on my runner, right? You can do that, and you can save your change. So I have a runner running on my laptop. I have registered, and now I'm going to actually do something to trigger a change. I need a file here, so which is this file. This file has to be named by .gitlab -ci.yaml, YMA. And so this is exactly kind of capture my script that you saw early on, right? You define stages. You can name your stage by however you want to name it. It's those build, test, clean up, test, deploy is not a keyword. Stage is keyword, okay? So you can say compile, packaging, you know, depending on your use case. And when you define this, this is sequential. The system will execute these stages by sequence. You can also do parallel. Say if you want to package something for your customer, right? You want to have a zip file. The other customer want an ISO file. This can be parallel. In that, you can define a packaging stage, and you can use stage packaging, and so they will run parallel. So it's quite sophisticated, actually. And then I build image by doing exactly Docker, you know, build and Docker push. Then I test. I do the same thing. I run it on a special port, and I curl that port, and I clean up myself. You know, remove the artifact which is no longer useful. And then in the final stage, I do deploy. In my deploy, I say I want to run it on shell runner, and I also I remove if there's a container already running by that name, I remove it, and I start a new one on port 80. You realize, you see the testing one is running on different port, right? So for my testing. Okay, now we have YAML file, and I want to change something, so I can trigger the job, so we can all watch things happen. So I have that in my Docker node app directory. It's always a good idea to actually, when you do something in your local repo, you pull, try to sync up with your upstream locals, just in case anybody else changed it. So I'm going to just change an image in this case. I think the index. All I'm going to do is actually change an image. Stanford 125. I have this image on this repo. I changed that and make sure I'm terrible with typing. So that looks okay. I'm going to commit it, right? The catch. So I'm going to change to Stanford logo, no logo picture. And I push. Before I push, I need sure. So this is my current logo, my current picture running on the production on my laptop, right? So I'm going to commit this one. This is supposed to really trigger my CI job. My CI job is up in the cloud, in the AWS, and my scheduler, and my job actually running on my laptop. Joanna is on my laptop. Go back here. If I go back to my Docker repo, okay, I can see my job actually is running. And you can actually see what is going on here. It's not exactly what I told it to do. It pull the image, it build the image, and after it's built, it will push into my Docker Hub account. It's actually pushing, right? Pushing for those are not familiar with Docker, actually is that it's pushing to Docker Hub. And that build is success. I'm not sure why it doesn't select me. So then from here, you can see it's moving to test phase. So it's finished build phase and now it's moving to test phase. So it should the test actually testing on my local port and build success. So the testing is also okay. Now it's moved to clean up my test job, which basically remove all the things that no longer in use, the image, the old ones. And when this finishes, okay, now we are into deploy phase. Okay, this deploy actually finished. It's finished. So if I reload this one, it should show new image. Yeah, Stanford. Yeah. It works, right? It works. Huh? Yeah, it works.
So if that's running on your laptop, do you need to have certain firewall ports opened up, or how does that?
Technically, the runner running on the question. Okay. How does it work?
How does it work with firewalls?
Oh, this is outgoing call, right? I mean, this one talks to, well, my runner is outgoing call. It's persistent connection actually.
Polling?
It's
already existing connection, so it can push back down again.
When it registers with the server, the question is really how do you bypass all the firewall rule? How does this work, right? It's actually the GitLab is for 3 API port, right? That is open, and your machine is outgoing call. Okay. When you register with the GitLab, it shares a secret token between them, and that job actually long running on your laptop. And
if you put it in your computer, you would have to be done.
Yeah. If I
Simply you set up as a launch. So it started like on a Mac.
If I close my machine, it will not work. Right. Yeah. The laptop, I have to log in, in order for it to work. But you may maintain a machine, very powerful machine in your data center in somewhere else that you have control, that you can actually do this for your production, right? This is just for demo purpose. I actually should see some, a lot of here, my notification going on here. It's pretty new for 20. Tell me something going on with my system. Now I actually have to find where's my demo. I accidentally closed it. I haven't finished yet. Okay, let me go back to my my slides here. Just actually summarize of all we did today. Okay. So we actually, I think we did what we promised to do. Right? We covered everything. And these are the references that you can read on when you have time. Anytime you are on Code Stanford DDU, if you type /help, all the documentations are in there. API and group and permissions and everything's there. If you are interested in the CI demo, the code, how to install my runner, I have that link in there. You can also go and download and play with it on your laptop. With that, let's have FAQ. And before, I want to actually check while we are talking, did we pick up any new people? I'm just, okay. We did have quite more than 20 people sign in for today. You're welcome on board, online, in person here. So that's introduction. We are really taking care of it. So please do enjoy this thing. And FAQ, Q&A, yeah.
So the links that you just showed, where did they help with? They are one of the pages.
Or they'll protect briefing. Where are those links? How do I click on that?
Oh, I need to share this thing.
So what we can do, since we are recording this session today, we will edit it up on the Tech Briefing website within the Code Briefing. And so you can go to techbriefing.stanford.edu. We'll have off of that page a link to the video, which will have these resources. That page is going to work that time.
Don, can you say just, I don't know if the online people can experience.
I'll type it into the Blue Jeans chat.
Oh, okay.
Well.
Yeah, I sorry, we didn't share that. You cannot really click, poke, poke at it. Yeah.
I have a question for people who want to collaborate with people at Stanford. Would it be okay if they use their GitHub account to authenticate? Does everyone you collaborate with have a GitHub account? That would work for people?
So we'll take that back. We're interested in getting feedback. So you understand, we started with sort of internal GitLab instance, and the integration sort of scaled it up. We had business peers have access. We're sort of opening it up more broadly, but we're doing it kind of in waves. So we're just trying to get this out there sooner rather than perfect and bulletproof and enterprise scale whatever. We want to get it more available to support more collaboration in an organic way that we see really a big gap, as Jen was saying before. So we're gonna look for mechanisms for you guys to submit requests for other enhancements, but we don't really have a really formal process right now. So give that, it's a little roughly hewn, but it's sooner rather than later. Okay. Well, we're fine to have a conversation. Yeah.
So we waited to actually quite long. We announced this to UIT in February, and back then AWS EFI system performance is really bad. So we waited until it wasn't until June 21st something. Finally they released EFS as GA, and the performance is much better. So that's why we feel comfortable we can actually release this.
You also mentioned something about how we're thinking about some bounds, some limitations of how much we want people to show. Well, we were toying with some limits.
If nobody asked me, I don't want to bring it up. Well, I'm just joking. Okay.
There's no large file support.
Oh, okay. So if nobody asking me, I'm going to bring it up. Okay, the storage, right? That's really, what how much file I can put in there. Basically, it's a code sharing platform. It's not, you are not going to put your genome, research data in here with terabytes. We can't do that, right?
That's what Google Drive is for.
Yeah. So don't put BA content in there. Don't really put your large, your patient scan image on there. And usually, if you look at GitHub storage recommendation, they said it's 1 gig, your repo. If you go over 1 gig, you get a courtesy notification, and they recommend you to break up your repo, basically, because for performance. I'm talking GitHub. Yeah, GitHub has that policy. I think we are going to follow them that way. And if you are over 1 gig, there is actually large file system support.
Oh, we do have it?
Yeah, you do. Yeah. The large file system means that you define this file or something in this folder is large file. There's a command I forgot, but if you search for GitLab large file system, and that way it will be outside of your repo. It's in a special repository, so that does not count as your performance, penalty, things like that. Yeah.
What if the data talking about something data classification board or putting just the lowest level, I guess.
Yeah, for now.
There's no BA, and other than that.
Data classification as far as
Ima and other people ask about data classification, what kind of data we can put on there. Bruce, you want to answer that because you are more in the management role? Moderate?
You don't want to put for private, you don't want to put something really sensitive, confidential. You want good hygiene in terms of separating out things that are data or whatever, separately from what's essentially a revision control system of code. Right? So think about it that way, and we want it for the future to be in good practice. But the discretion of, we don't have a business agreement, so no PHI up there.
Yeah, no.
And we are going through iterative security reviews for maybe higher classifications for the probably in the fall. But for right now, just think of it as you would think of box. I guess in terms of how you think.
Stanford box, not Roscoe box.
Yeah, exactly. Yeah, exactly. Thank you. Not Stanford box.
I mean, you do need to stick random credentials in there. There's a great so-called decrypt that will PGP encrypt all the sensitive stuff before it gets submitted, and it'll PGP decrypt it when you bring it back. So we will get that script and handy for things like that, and you can use it in Team to all encrypt stuff. Once you have it set up for specific files, it's pretty much enough part.
Well, one of the motivations we had of this also is because we know that we have contractors or people that kind of might come and go as staff members do development, and a lot of things.
One second, before that guy speaks up, he's been a guinea pig for the last year and a half, so he's the one who's given us most of the feedback so far, and he's been our guinea pig. So thank you, John.
Yeah, guinea pig for Docker technology, for container for this GitLab. It's in the lab environment for a very, very long time, and we bring it out to production quality. Yeah.
What I was going to say is just a place that's more official now centrally, where we can escrow code built on our behalf by folks that might come in and out of teams. We thought this was really good investment protection for the institution in general. And we've seen it with mobile app development. Some group gets hired and get a student that comes in and does some work over the summer or something like that. And this is the place to put stuff that you make resilient, make it back out into the central identity management.
It's interesting nobody bring up the account lifecycle. But we are working on that. We are definitely going to have a process in place to block people who left Stanford. Even they cannot log in. If they have key, they may still be able to access to the repo, right? So we are going to do a cleanup maintenance that will block, if not remove, non-Stanford account. invited Stanford account.
So I think the integration.
Definitely that can be, because API is already there, we can do that. But after this half year, it's try this out, it seems that most group has mixed membership. Yeah, they take somebody from here, somebody from there. It's very quite, if you do work group only, I don't know how much.
Well, I'm thinking the auxiliary to what groups you have. I'm thinking in the sense that, say, if a group has a set lab group of people who are working on something, and they have turnover something else on the campus rather than out the campus proper.
Yeah, I think that's a good suggestion. We should have some resources to do that. Yeah, feature request.
And it's also something that we looked at a while ago, and it was going to be just complicated because no way your SAML which could partition it. There was this statement from GitLab developers where in that regard, SAML has been really important, even for edition. So GitLab has the free community edition, paid, no price expenses, GitHub Enterprise Edition. But they actually committed to supporting SAML and groups for both editions. So now our group would do strong groups of SAML, we just haven't had a chance to set it up.
Yeah, that's down. It becomes more established than what we're forward.
So before we are 5 minutes over. If people want to leave, please feel free to go. And if people want to stay here to talk more about this, we are here. Okay, Mo, Marcello, we are here to continue to discuss it. But if you want to go, catch up your bus or train, whatever, feel free to go. And thank you so much for coming over. Thanks. Okay. Thank you.
I've only this conversation with